Hello, guys. I hope you are doing well. Welcome to my YouTube channel, which is Data Science Gurus. And in previous lecture, we have discussed in detail about the classification algorithms, and then we have discussed about the practical implementation in Python and how to install the Python IDE, and then we have discussed in detail about different libraries and practical implementation on the real world data set. Today, we will discuss more about supervised machine learning and algorithms and what and how they actually work and what are their real world applications. Okay, so let's take an example. So, supervised machine learning, as I have discussed before, is a type of machine learning in which we are going to classify the data. So, basically, we have the data set and we are doing the classification problems. Okay. So, for example, an emergency room in hospital measures 17 variables, for example, blood pressure, age, and other ones of newly admitted patients. So there's an emergency hospital, and we have different variables like blood pressure, age, sugar level, and a lot of other features. So we have to classify these patients uh, between the high risk and the low risk patients. So how we are going to do that? Okay, so we have to make the decisions actually. So we have, for example, we have 1000 patients, and we have to classify between high risk and low risk on the basis of the features like their blood pressure, age, uh, like their cholesterol level and other features. So due to high cost of ICU, those patients who may survive less than a month are given higher priority. So the all those patients who are at high risk, they need ICU. So we have to classify the patients between the two classes, the high risk patients and the low risk patients. So, for example, if you have 1000 patients or 10,000 patients, like you can take an example of COVID-19. So, like you have different, the data, if you're doing manually, it will take a lot of time. So, what you will do is you will take help from the machine learning, you will take help from the supervised learning algorithm, and that's how you can train a machine learning model, and you can give the features, and it will give you the results that whether the patient should be at high risk, should be in the high risk category or in the low risk category. Okay, so here is a second example. For example, a credit card company received the thousands of applications for the new cards. So each application contains information about an applicant's age, marital status, annual salary, and outstanding debts and credit rating, and so on. Okay, so to decide whether an application should approve or to classify applications into two categories, approved or not approved. So basically, for example, there's a bank uh, who has received a lot of applications in thousands, for example, 10,000, 20,000 applications, and they have to approve the loan for each of the customers. So this is not possible for people to just study these files. For example, in 1 week, they cannot process the data of 1,000 or 10,000 people in 1 week. Okay, so how you can get rid of this problem? You can simply design a machine learning model, and there are two classes, and you can have the data set. You can design a machine learning algorithm, and it will give you the actual results that whether this person's, according to the features like age and annual salary and outstanding debts and credit rating and other features, that this person should be approved for the loan or not approved for the loan. So that's why it is very difficult for us, and it's in fact impossible for us to process the 10,000 files, 10,000 records of the customers, just to classify between the approved and non-approved loans. So that's why here we can easily design a machine learning algorithm we can give it the features, and it will give us the results actually, that whether this person should be approved for the loan or not approved for the loan. Okay, so machine learning and our focus, like human learning from past experience, machine actually learns from the past experiences. For example, if you want to predict the Bitcoin data, so what you have to do is you have to give your machine learning model the past data. It will analyze it, it will extract the features, and then it will give you the results. Okay, um, like computer does not have experiences, for like you have to consider computer as a child. You have to teach it. Okay, like it will get the features from the data set. So the most important thing, as we have discussed before in our previous lectures, the most important thing is the data set. A computer system learns from the data, which represents some past experiences of the application domain. Our focus, our main focus is to learn a target function that can be used to predict the values of discrete class attributes, approved or not approved loans, and high risk or low risk patients. The task is commonly called as supervised learning, classification, or inductive learning. Okay, so what is the difference between supervised and unsupervised machine learning? The basic difference between supervised and unsupervised machine learning is that in supervised machine learning, you have the data set, and the data set is a labeled data set. For example, if you want to train the model, you have 100 records for different clients. So you have the past data of the people. So the past data in the past data you have that, that for these, if a person has a low credit score, and if a person is of this age, and the salaries of this range, so this person is not like it's the loan is not approved. So by this way, you give the previous data and you predict by giving it the features as an input, and it will give you the output. Okay, so this is called as the supervised learning, classification, or inductive learning. Okay, so the data and the goal, the main thing for your machine learning and deep learning, and for your research purposes, the main thing is your data set. If you don't know about the data set, you cannot design a machine learning model. If you don't know the attributes, you cannot design a machine learning model. Okay, so the main concern is the data set. So what is the data set? That, as we have discussed before, actually, for example, if you want to classify pictures of different, like, males and females, so you have to train the model for the previous pictures of the males and the females with their labels. So when we know the labels, the problem is the classification problem. So this is why the data is very important, because if you don't have the data, you cannot design a machine learning algorithm or model. Okay, uh, you know about the data, a set of data records, also called examples, instances, or cases, described by key attributes and classes. What is the main goal? To learn a classification model from the data that can be used to predict the classes of the new, future, or the test cases or instances. So your main goal is to predict that whether a patient should be into the high risk class, in the low risk class. Okay, so this is your main goal. Okay, so for example, we have the records for 15 students. We have age, has job, on house, and credit rating. So basically, you can see there are four features, and in the last column, which is named as class, so this is your class. So we have four columns that are the basic features, and the last one is your class, that whether this person was approved for the loan, or not approved for the loan. So by this way, this is your data set. Like, usually, if you have the, like, 100 records, and if you have 1 lakh records of the clients, then your model will learn more features from 1 lakh records as compared to 100. So the performance is actually based upon the data set, the number of samples. If you increase the number of samples, you will be having a better accuracy. If your samples are less, then you will be having low accuracy. Okay, so that's why the more the data is, the more better the performance is. Okay, so here in this example, there are four classes. There are two classes. This is your classes, yes and or no. It means approved or not approved. And these are the features: age, has job, on house, and class rating. According to these features, you can predict that whether a person should be approved for the loan or not approved for the loan. So this is the basic example that how machine learning actually works. So how it's going to work is it will extract the features from these four columns, and then it will predict the next class for that specific, according to those specific features. Okay, this is how it works. Okay, so supervised learning classification is seen as a supervised learning from example, supervision, the data observations and the measurement. What is supervised learning? We are doing the supervision from the data, and then we are classifying the data between different classes. Here we have two classes: approved or not approved. If you have, it's a binary class classification problem. If you have more than two classes, then it's like you have to predict three classes. Okay, so you can have also four classes, five classes, it depends. Okay, but it's when you have more than two classes, it's called multi-class classification. Okay, supervised versus unsupervised. Unsupervised learning is basically a clustering. Class labels of data are unknown. For example, if you have the data and you don't know the class labels, then this is called as clustering algorithm. Okay, so there's a difference between the classification and clustering. In classification, you know the labels, but in clustering, you don't know the labels. And what are the labels? This column are the label. For example, if a person is young and he don't have the job and he don't own the house, and the credit score or credit rating is fair, so the loan will not be approved for that specific person. Okay, so this is how it works. So this is a label. If you have these four features and you don't know the class, so this is called as clustering problem or clustering algorithm. Class labels of data are unknown. Given a set of data, the task is to establish the existence of classes or the clusters in the data. Okay, supervised learning process. We have two steps. Special first one is the learning, and the second one is the testing. So learn a model using training data, testing. Like for example, if you have 100 records, so you have to split the data between the training and testing. 80% of the data will be used for the training, and the 20% will be used for the testing. So the model will learn features from the 80% of the data, and then it will do the prediction on 20% data. The most important thing is the 80% data is the seen data to the model, and the rest of the 20% is the unseen data for the model. For example, and you can, when you have done your training and you're done your testing, then we have the different performance metrics. For example, if you take the example for the loan approval for the client, like client gives an application and he has some features like age and other ones, and then you have to predict that whether the person should be approved for the loan or not. So first of all, we have the training data. We pass this training data to the machine learning algorithm. Machine learning algorithm or model will actually extract the features from it and will learn features. Okay, after that we have the test data, which is unseen data. Okay, and then we have to test when the training is done, we have to test our model. So we have to do the testing on the unseen data, and then we have to evaluate our model by the help of different performance measuring metrics like precision, recall, accuracy. So what is accuracy? So accuracy is number of the classifications divided by total number of test cases. So the correct classification and total number of cases, you will be having accuracy in percentage, like 40, 50, 70, 80%, 90% accuracy. And then we are evaluating our model with the help of this performance measuring matrix. Okay, well, what do we mean by learning? When we extract the features, and for example, if you want to, like computer is like a child, so you're giving you're showing the pictures of cat to the child, and you're telling the child that okay, this is a cat. Okay, after that you're showing the pictures that okay, this is a dog. So what actually the machine learning model will do is it will extract the features, and then on those features it will remember it, or it will, just like a child, it will remember it, and it will do the, like it will remember it with the features and with the label. For example, if it will remember the features for the cat and save it with the cat, and then basically cat is a label. And how it is going to do that, it will be done by the help of the data set. Okay, so this is how it works. Example: data, loan application data, the task, predict whether a loan should be approved or not. Performance measure should be the accuracy. So classify all future application test data to the majority class. Yes, accuracy is 9 or like 15. And okay, so how it's gonna work? So how it show that how it gonna, where this 9 comes from. So we have two classes, approved and not approved, and the data is, and the data set we have 15 samples. Okay, so you can see here we have the 15 samples, and if you count the number of yes in this data, the number of yes are 9, and the number of no's are 9 minus 15 minus 9. Okay, and after that, how you are going to predict the accuracy is the total, is the number of the predictions divided by total number of the samples. So here the samples for yes are 9, and 15 are the total samples. So 9 over 15 is 0.6, so which is the accuracy, 60% accuracy. Okay, so fundamental assumption of learning: the distribution of trainings examples are identical to the distribution of test samples, including future unseen examples. In practice, the assumptions is often violated to a certain degree. Strong violation will clearly result in poor classification accuracy. To achieve good accuracy on the test data, training example must be shown sufficiently representative of the test data. So this is how it works. Actually, you have the training data and the testing data. So for example, you have the 100 samples, 100 records for different uh, clients. Okay, 100 applications, for example, in a bank, and you are going to train the model for 80 clients, and then you are going to predict, or you are going to evaluate the model on the 20 clients. These 20 can be random. It doesn't depend that there should be first 20, last 20, mid 20. So it doesn't depend. So that's how it's worked. Okay, so we have different classes: supervised machine learning algorithms. The We have discussed the support vector machine, which is a really good machine learning algorithm for binary class classification, and you can get the better results. After that, we have the decision trees. So what is the decision tree? Decision tree learning is one of the most widely used technique for classification. Its classification accuracy is competitive with other methods, and it is very, very efficient. The classification model is a tree called decision tree C4.5 by Ross Quinlan, perhaps the best known system. Okay, so how it's gonna work. So for example, like it's going to classify approved and non-approved cases by the help of decision tree, by making a tree, and then it's gonna make the final results. Okay, so for example, we have the, as we have discussed it before, we have 15 samples in this data set. We have four features, which are age, has job, on house, and credit rating. And we have the final label, which is the class. Okay, and in class we have we have two labels, which is approved or not approved. No means not approved, and yes means approved. Okay, so decision tree from the loan data is, for example, it's gonna make the different, like it's gonna check it on age. So age, for example, we take an example for this column. So in age we have three classes: young, middle, and old. So it has age, young, middle, and old. So it has split the young, who has a job, into true and false. So a person with the age of young has a job, is split it into two columns, which are, if he has a job it's a yes, if he don't have a job it's a false. So the total number of yes are two, and it's 2 by 2, and the false are, there are three false, so there are 3 by 3. Okay, same case in the middle, the age is middle. Then, and a person, if the age is middle and the person owns a house and the loan was approved, the total number was 3. Okay, and the loans, if a person age is middle and he don't owns a house, so it relies in this category. And the same for the old one. Okay, so using a decision tree, so we have just give it a sample. For example, if the age is young, if a person don't have a job, if a person don't owns a house, and the credit score is good, then what should be the decision for the loan? Okay, so we are now giving it like a test example, that if a person age is young, if he has a job, if he don't have a job, and if he don't owns a house, and the credit score is good, so the loan application should be approved for that specific client or not. So after this whole learning, we just know that if we have these four features, like these four scenarios, then a person's loans application should not be approved. So this is how the decision tree actually works. Okay, evaluating classification methods: accuracy, number of correct classification, total number of test cases, efficiency, time to construct the model, time to use the model, robustness, handling noise, missing values. It's a very important thing that if you have the data, you have to pre-process the data. You have to remove the null values. You have to deal with the missing values, the noise. You have to remove the unwanted data from it. Scalability, like efficiency in disk resident databases, interoperability, understanding, and insight provided by the model, compactness of the model, size of the tree, and the number of rules. Okay, evaluation methods: holdout sets the available data set D is divided into two disjoints. As I told you before, when you're designing a machine learning model, you have to do the two steps: the training and the testing. The 80% will be the training, and the remaining 20% will be for the testing. Okay, then how and cross validation gonna work? For example, if you have the 100 records for the different like for different clients, and you want to train the model on 100 records, okay, and you have splitted the data for training and testing. So the first 80% is for testing, and the first 80% is for training, and the remaining 20% for the testing. So in this scenario, if you're doing like splitting the data like this is not the right way. So what you can do is you can do the k cross fold validations. Okay, for example, it should take the for the training, it should take the first 5 samples, last 5 samples, and it should take the increment. Okay, and if you are doing such an evaluation like a validation method, then it is called as n-fold cross validation. For example, you're randomizing the data. Okay, the available data is partitioned into n equal sizes, disjoint subsets, and if each subset as a test set and combine the rest n minus 1 subsets as a training set to learn the classifier. The procedure runs n times, which give n accuracies. The final estimated accuracy of the learning is the average of 10 accuracies. So it has to make the folds, like it has to make the small parts like 10 or 5 or 15, and then it will do the training and the testing. This method is used when the available data is not large. Evaluation methods leave one out cross-validation. The method is used when the data is very small. It is a special case of cross-validation. Each fold of cross-validation has only a single test example, and all the rest of the data is the training. If the original data has m samples, then the m fold validations will be done for cross-validation. Evaluation method is validation set. The available data is divided into three subsets. So when you're including the validation, you have to divide the data into three: training, validation, and test. Validation set is used frequently for estimating parameters in learning algorithm. In such cases, the values that give the best accuracy on the validation are set the final parameter values. And each validation can be used for the parameter estimating as well. Okay, so backpropagation is the systematic method for training multi-layer. Okay, so this is all for today. Like we have discussed in detail about supervised machine learning algorithms and performance metrics, decision trees. Okay, and we have also taken the practical example to make you more clearer and the more broader way, so that you can learn things very easily. Okay, and in next lecture we will discuss more about uh, other supervised machine learning algorithms so that you can have a uh, basic idea that what are the machine learning and how you're doing training and testing. Okay, don't forget to subscribe our YouTube channel. Thank you so much. We'll see you in the next video.